A sodium atom contains 11 electrons, 2 in the first energy level, 8 in the second, and 1 in the third. A chlorine atom has 17 electrons, with the outer level holding 7 electrons. When sodium and chlorine combine, the sodium atom loses 1 electron and the chlorine atom gains it. Thus, the chlorine ion formed is stable with 8 electrons in its outer level and has a negative charge. Sodium has lost the 1 electron that was in its third energy level. Thus, the sodium ion has a positive charge and is stable. Sometimes atoms combine by sharing electrons to form covalent bonds. Hydrogen gas exists in nature as diatomic molecules. 2 hydrogen atoms share electrons with each other. The electrons move around the nuclei of both atoms. When 2 hydrogens share electrons with oxygen, they form covalent bonds to produce a molecule of water. Each hydrogen atom shares 1 electron with the single oxygen atom.
Here we have an atom of zinc. This atom of zinc is only showing the valence electrons. I haven't drawn in any of the others. So we have the 2 valence electrons for zinc. And what you would notice is, in a metal, the valence electrons are actually not attached to the atoms themselves. They're what we call delocalized. They're free to move around. And it looks something like this. The electrons are free to move around. They're not stuck around this particular nucleus. And we have a zinc ion and then free floating negative electrons. So zinc 2 plus and 2 negative electrons floating around. This is for a single atom. If we looked at an entire sample of zinc, we would see something that looks like this. A whole bunch of zinc 2 pluses, these big blue spheres, surrounded by electrons, what we call the sea of electrons. And this is metallic bonding.